So today we're just going to record our notes about relations and functions. So when does a relation become a function, or when is a relation considered a function? So the way that we're going to figure all of this out is we are going to make sure that we are able to determine when when a relation is a function, and we're going to do that by analyzing the input values in each of our relations. Okay, so let's see what I'm talking about when I say that. We know what a relation is. Okay, so let's write down the definition of a relation. I'm going to highlight my vocab words. We know that a relation is a set of, it's a set of numbers, but they're special numbers that we call ordered pairs. So they're a set of ordered pairs that can be written as a table, graph, or mapping diagram. Okay, so a set of ordered pairs that we can also write as a table, a graph, or a mapping diagram. So there's 4 different ways that we can represent relations. We know that. These are all things that we already know. Okay? Now, when does a relation become a function? When does a relation become a function? So let's write down the definition of a function, which we also already know. So we said that a function is a special type of relation. So it's a relation where every input has only one output. Every input has only one output. And I want you to write down in parentheses vending machines, because we can think to our vending machine example when we're thinking about functions. So in parentheses, I'm going to write that down so I can remember it if I need to. So a function is a relation where every input has only one output. I don't care how many outputs there are, but I just need to make sure that each input only has one output. I'm always looking at my input values when I'm trying to figure out what a function is. Okay, so what we're going to do right now is we're going to draw some examples of ordered pairs, tables, graphs, and mapping diagrams that are functions and not functions. Okay, so let's do that here. Okay, so I'm going to draw a line that goes all the way across. That wasn't as straight as I wanted it to be. There. I'm going to draw another line all the way across. And then I'm going to split it down the middle. Like this. And I want to leave a little bit of space at the end for my summary. Okay, so my first column is going to be called function. So these are going to be all of my examples that are functions. And my second column is going to be called not a function. It's going to be all my examples that are not functions. Okay? And you know I love highlighting, so I'm going to highlight these for myself. Okay, so the first example we want to do is ordered pairs. So when do ordered pairs look like functions, and when do ordered pairs not look like functions? Okay, so first we're going to have our squiggly line, and we're going to have the ordered pair 1, 2. let's do 2, 3, and 3, 4. Okay? If we look at all of our input values, they do not repeat. Do you see that? They do not repeat. They're all different. When I look at my input values, they are all different. So that means each input has only one output. However, let's rewrite some of these. Let's say I have the ordered pair 1, 2, just like my first one. But let's say the second one is 1, 3. And then we keep 3, 4. Do you guys see how my input repeats? This cannot be a function. This cannot be a function because my input cannot repeat. If it repeats, that means the input of 1 has 2 different outputs. That means the input of 1 has 2 different outputs. And I don't want that. So let's write that here. The input 1 has 2 different outputs. Right? And we said we do not want that. We do not want that in our function. All right, so that's it for ordered pairs. That's how we can tell if an ordered pair is a function or not. I keep drawing these not straight lines. Okay, there we go. Okay, so next we're going to do a table. Okay, so when is a table a function? When is it not a function? So I'm going to draw a horizontal table. Just like this. So it's a 2 by 10. I'm going to do the same thing here. I'm going to draw a 2 by 10. Okay, and then I'm going to split it up every 2 blocks. And I'm also going to split it down the middle. Okay? So we know that our values in a table are called X and Y values, right? So I'm going to label my table X and Y. And now let's go ahead and put some values in. So let's say for my first table I have 0, 2, 4, and 6. And at the bottom we can have, I don't know, 5, 10, 15, and 20. And if you notice, this is a function because I have different input values every time. My input values are different every time. However, in my second table, let's say I switch one up. So let's say I have 0 twice, and then I have 4 and 6. And let's keep everything else the same. I cannot have my inputs repeat. So this is not a function because the input 0 has 2 different outputs. It has the output of 5 and it has the output of 10. 0 has 2 different outputs, so that cannot be a function. Okay? So we are done with ordered pairs. We're done with a table, and we have 2 more. We have our mapping diagram and our graph. We have our mapping diagram and our graph. For our mapping diagram, okay, we want to draw our ovals. Okay, so I have 2 there. I'm going to do 2 more here. Okay, and mapping diagrams are my favorite because I think it's really easy to see if something is a function or not in a mapping diagram. So let's say I have 0, 1, and 2, and I have the output of 5. 0 has 1 output to 5, 1 has 1 output to 5, and 2 has 1 output to 5. So even though they all have the same output, every input has only one output. There's only one line coming out of it. Every input has only one line coming out of it. But let's say I have my same inputs, but now I have 2 outputs. If 0 matches to 4 and 0 matches to 5, that means 0 now has 2 different outputs, and we cannot have that in a function. So even if the rest of these guys are the same, because 0 has 2 different outputs, we cannot have that be a function. So we're going to write that again. The input 0 has 2 outputs, which is why it's not a function. Okay? And then finally, we are almost done. Well, we would be done if I could draw a straight line. Okay, there we go. The last one we're going to do is called a graph. Okay? And maybe I need more space. Let's see what happens. We can draw a little mini graph. It doesn't have to be intense. So I'll draw like a 4-unit line this way and a 6-unit line this way. And that can be my graph. Okay? So go ahead and draw that on both sides. Okay, so for our graph, we know that we use the vertical line test to figure out if our graph is a function or not. Because the vertical line test shows us if each input has more than one output. Okay, so for example, let's say I have this graph right here. And I want you guys to try to draw this the best you can. Okay, so this is my graph. I try to make it a little thicker so it's easier to see. Okay, let's say I draw a vertical line, right? I draw it right here. It only touches one time. Only one intersection, right? It only touches one time. That's okay. That means there is only one output there. So this is a function. However, let's say I have a graph that looks like a circle. Okay? And I draw a vertical line. Let's say I draw it right here. This has 2 intersections. So we can write that 2 intersections. That means there's 2 outputs. We do not want that. So that means this is not a function. This is not a function. So we have all of our notes now. The last thing I want you guys to do is write a 1 or 2 sentence summary of what we learned in our notes today, and then submit your notes as a picture on Google Classroom. But good job, guys. That was a lot, and I'm really proud of you guys for getting through that together with me.